Hello students, I am explaining chapter 2 is matter around a sphere for class 9 science, and in this video I am going to explain the answers for the questions which are present on page number 18. So as we all know, if you see your NCERT book, there are questions in between the chapter and that I am solving in this video. Once I complete these all, then I am going to solve the NCERT exercise which is present at the end of the chapter. So let's start with the questions present on page number 18. Question number 1 is differentiate between homogeneous and heterogeneous mixture with examples. So here we have to write the differences between homogeneous and heterogeneous mixture even with examples. So very simple question. So you see here, first I have written homogeneous, second column I have written heterogeneous. So remember, homo means what? Homo means equal, and hetero means what? Hetero means not equal. So by using this hint, we will start writing the differences. First difference is about the definition. So a mixture in which the composition is uniform throughout is called homogeneous. Uniform throughout means whatever components we have mixed in this, all will mix completely and you can see the composition uniform or equal throughout the mixture. Opposite, we can write it on the other side, that is a mixture in which composition is not uniform throughout. So if you see heterogeneous mixture, if you mix two or more components, they will not mix equally. Their composition will not be uniform throughout the mixture, and those are called as heterogeneous. So this is about the definition. Now we will see the second one, that is components can be separated. See here, sorry, components cannot be seen separately. So in case of homogeneous, whatever components we have mixed, all will mixed so clearly and so thoroughly, we cannot separate them. We cannot separate them. But in case of heterogeneous, components can be seen separately. We can see clearly how many components we have mixed in this heterogeneous mixture. By seeing example, you will understand. But remember now, in homogeneous, we cannot see all the components separately because they are completely mixed. In heterogeneous, we can easily distinguish how many components we have mixed into the mixture. Third one, that is about phase. So in homogeneous, all will have one phase. Like there are phases called solid, liquid and gaseous. Whatever components we are mixing in homogeneous, but all will mix and they will show one phase, either solid or liquid or gas. But in heterogeneous, as I told, they will not mix together. Their composition is non-uniform and even we can see them separately, and therefore you can see two or more phase. You can see solid as well as liquid. You can see solid as well as gas. And even if there are two liquids, even we can separate those two liquids very easily. This is all about heterogeneous mixture. The next difference, that is fourth one, same properties throughout the mixture. Because it is completely mixed in, because it is uniform, once the mixture is formed, the properties will remain same throughout the mixture. But in heterogeneous, they are not mixing. All the components are not mixing. The composition is not uniform. We can easily see the separately all the components, and therefore you can see here properties vary from one part to another part. So if you are mixed here, say A plus B plus three components, if you are mixed, in this mixture also we can easily see the properties of A, we can easily see the properties of B, even we can see easily the properties of C. But in homogeneous, if you mix A plus B plus C, after getting a mixture, you cannot separate the properties of A. You cannot see separately properties of B. Even we cannot see separately properties of C. All together will have same properties. This is the meaning of the sentence. And the last, that is called example, because in the question you can see they have asked us to write the example. So here in homogeneous, example is salt dissolved in water, air, sugar solution, that is sugar dissolved in water. Salt is solid and we are going to dissolve in water, so water is liquid, but once it gets dissolved, it is called salt solution. Composition will be uniform. If you see the taste, it will be same salty everywhere, and even the phase you can see it will be liquid. You cannot see solid salt in that solution because whole salt will get completely dissolved. But in case of heterogeneous, we can see oil and water, sand in water or soil. If you see oil and water, oil will float and water will be at the bottom. So we can easily separate this oil and water. There will be a boundary between the oil and water. So this is called non-uniform. Even if you put sand in water, as I have told you earlier while explaining the chapter, sand will settle at the bottom, water will be on the top. We can easily separate this sand from this water. And you can see two distinct phases. One will be solid, that is sand, and this water will be showing liquid phase. So I hope you're understanding the answer. So in this question, we have written the differences between homogeneous and heterogeneous. Sometimes the question will be, what is homogeneous? Give example. So in that case, you have to just write about homogeneous and its example. Sometimes they may ask same thing for separately heterogeneous. So you have to write just about heterogeneous and example. But if they ask differences, you have to make two columns and write like this. So remember this answer. Now we will move to the next question. Question number 2. What are solution, suspension different from each other? Sorry. How are solution, suspension different from each other? So here again we have to write the differences between solution and suspension. So start solving answer. The first column I have written solution. Second column it is sol, that is nothing but a colloid, type of colloid. And third column I have written suspension. So now see here, first difference, homogeneous mixture of two or more substances. So what is solution? It is a homogeneous mixture of two or more substances. What is colloid then? Colloid in which solid particles are dispersed in a liquid. So these all are definitions. So what is colloid? It is a mixture in which solid particles are dispersed in a liquid. And what is suspension? Heterogeneous mixture with large particle. So remember, first one is homogeneous, that is solution. Second one, colloid, is a mixture where solid particles are dispersed, but still it is a homogeneous. But suspension, it is a heterogeneous mixture. Second one, write down about the homogeneous and heterogeneous, the same thing which just now I told. It is homogeneous. It is heterogeneous but appears homogeneous, but many of the time it is called homogeneous only. So you can refer the same sentence which I have written in these notes. That is, it is heterogeneous but appears homogeneous. And suspension is almost all heterogeneous, and it is based on the size of the particle. So you can see here the particle size is very small in case of solution, that is less than 1 nanometer. Nm is the nanometer, that is measuring unit used to measure the size of the particles. So in solution it is very small. In colloid it is intermediate, means the particle size is between 1 nanometer to 1000 nanometer. So that's why 1 nanometer to 1000 nanometer means it appears, whenever it will be 1 nanometer, it appears homogeneous, but actually it will be heterogeneous. In suspension, particle will be of bigger size, therefore it will be greater than 1000 nanometer. The next one, not visible. Remember, these are not visible, don't show Tyndall effect. So these will not show Tyndall effect because the particles are so small, they are not at all visible, they are not able to scatter the light. Second one, colloid, not visible to naked eye, show Tyndall effect. So in colloid also particles are not visible, but even they can show Tyndall effect, that is scattering of light. In case of suspension, as we all know, particles are so big they are visible to the eyes, that is naked eyes, and may scatter light but not clearly like colloid. Because the particle size is so big, they are not able to scatter the light like colloid. Colloids are the correct size particle to scatter the light or to show this Tyndall effect. So remember, solutions will not show Tyndall effect, colloids will show clearly Tyndall effect, suspension may or may not show Tyndall effect. Next property, solutions, the particles are stable. Stable means do not settle. They are so small, they have very less weight, they will not get settled. In colloids, quite stable, do not settle, but particle sizes, you can see the size, it is between 1 nanometer to 1000 nanometer. So some particles may get settled, some particles may not get settled. That's why it is said quite stable. But suspension, it is completely unstable. The particles are so big, they will settle down. So it is called unstable. The next property, cannot be separated by filtration. We cannot filter it by using funnel and filter paper because particles are so small they can easily pass from the holes of the filter paper. So we cannot separate it by using filtration. But in colloid, cannot be separated by ordinary filtration. So by using simple filter paper funnel, we cannot separate it, but by using some advanced filtration technique, we can separate it. So it is ordinary means we are not going to use any advanced technique. In case of suspension, cannot be separated by filtration. Sorry, can be separated by filtration. So here particles are so big, when we take a funnel and a filter paper on the funnel here, and when you pour the solution from this filter paper, these all the particles filter paper because the size is very big, and the filtrate will come down into the beaker. So this was about the filtration. And the last, that is about the example. So in solution, the example is salt solution, sugar solution. In colloid, the example is milk, paint, starch solution. You maybe have seen milk. To look, it will be white in color. You put any amount of water, but still it will be white. But you cannot see the particles in milk. Even the paint. Paint also you cannot see the particles because particle size is between this 1 nanometer and the 1000 nanometer. But in case of suspension, the example is muddy water, chalk in water. If you see muddy water, it will have smaller as well as bigger particles. All it will have. So that's why this example is for suspension. So these are the differences which I have given between solution, colloid and suspension. So remember, sol is nothing but one type of colloid. So if they use the word colloid or you are using the word sol, remember it is both are same. Now we'll move with the next question. Now the question number 3, to make saturated solution, 36 gram of sodium chloride is dissolved in 100 gram of water at 293 Kelvin. Find the concentration at this temperature. So we are going to prepare a saturated solution of NaCl. What is saturated solution? It is the state where no more solute will dissolve. That is called saturated. So we are going to prepare the saturated solution of sodium chloride. And for that, we have weighed 36 gram of sodium chloride, that is NaCl. And we are going to dissolve in 100 gram of water at 293 Kelvin temperature. We have to find the concentration. So the formula used is mass percentage and is equals to mass of a solute divided by mass of a solution into 100. Now see here, for solute, that is NaCl, and for solvent, that is water, we have a mass. It is in grams. You can see it is in grams. So it is a mass. So that's why we are going to use mass by mass percentage. So the formula, mass of solute divided by mass of solution into 100. So what all given? The solute is NaCl, it is given 36 gram. Solvent is water, it is given 100 gram. And when you mix the solute and solvent, we are going to get a solution. So remember, what is solution? To prepare solution, we require one solute and it should be mixed with the solvent. Then we will get a solution. So now we are going to add these two values to find out the mass of solution. So mass of solution is equals to mass of solute is 36 plus mass of solvent is 100. We will get 136 gram. Now according to formula, substitute the values. Therefore, I will write here mass percentage is equals to mass of solute is how much? 36. So I wrote 36 divided by mass of solution is how much? 136. So I write it 136 into 100. So this we have to solve to find out the final answer. So let's solve this. So I'll take two tables. So 2 ones are 2. That is 1 will remain, 2 8s are 16. 2 6s are 12. 1 will remain, 2 8s are 16. Then again 2 9s are 18. 2 3s are 6. 2 4s are 8. So I got 9 divided by 34. Now I can cancel on this side. So 2 1s are 2. 2 7s are 14. 2 5s are 10. 2 zeros are 0. So what I have got now? I have got, I'll write here mass percentage is equals to 9 divided by 17 into 50. So now multiply this 9 into 50. What I'm going to get? See here, let me multiply it. 50 into 9. So 9 zeros are 0. 9 fives are how much? 45. So I'll write it here 45. So we got our answer. So let's solve it on the other side. Therefore, I'll write mass percentage is equals to 450 divided by 17. So now we have to divide this 450 by 17. Let me divide. So first 17 twos are 34 we will take. So minus the 1 will remain. So 17 6s are is 102. So I'll write it here. Minus 10 minus 2 will be 8 here 1. So 0 0. I will write here 0. Therefore it will be decimal here. And now we can use this 17 table. So 17 4s are is 68. So if I take 68 here, it will be 2 carry 1, this 1, again 0. Now again 17, how much are we can take? 17 sevens are we can take, it is 1, 1, 9. Then it will be 1, 0, 0, and again we can continue. So here we will stop and write down our answer. So what is the answer here? Mass percentage is equals to 26.47 percentage. So like this we can write down the answer. So this is the concentration of this salt solution to prepare a saturated solution. I hope you will understand the solution of this sum as well as the answers which I have solved for earlier two questions. After this, I'm going to solve the questions which are present on the next page, that is page number 19. So I hope you're understanding this all the explanation. So if you like my videos and if you're getting little bit also help from this all the videos, then please consider subscribing my channel. Thank you so much.